I'm Shawn Kyzer, Associate Director of Data Engineering at AstraZeneca. And today we're going to talk about a data governance paradox. What do I mean by that? Well, the more data that we bring on, the more quality data that we bring on, the more value that we have, right? If we build the data in the right way and build it data as a product. The more valuable data that we have, typically that data is a little bit riskier. It's PII. PHI, right? Health records, personal information. The riskier that data is, the more we need to mitigate those risks using governance. Unfortunately, the more traditional data governance we apply, it kind of creates some issues in how agile we are. So we apply more data governance, but we become less agile. So then that brings us all the way back to the top where we want to bring on more valuable data, but because we have so much governance, it's hindering our ability to do that. So how are we going to break that cycle? Well, welcome to the world of policy as code. Today, I'm going to lay multiple foundations for us to talk about this, right? So the first thing we're going to talk about is what are some of the challenges, right? Why do we even need to be doing this? And then the second thing we're going to talk about is policy as code from a theoretical perspective. And then we're going to set a framework so that we can talk about how we can embed policy as code inside our framework, which is data mesh. And finally, we're going to go through 2 practical use cases just to understand how these 2 things will work together in real life. And by the way, these use cases are from actual use cases in the industry. And then the last thing we're going to talk about, and it's important, this is the hidden layers, right? This is the final layer, is how all of this plays into AI oversight, which is coming very soon, especially with the new EU regulations. Okay, so the challenges of data governance. One of the biggest things that we have here is we have these people making policies with great intentions. Unfortunately, sometimes when the rubber hits the road, implementing these policies like GDPR is really kind of a challenge. But if we don't do it, it's very expensive. And it's not just monetarily expensive. If a company or corporation doesn't comply, not only are they fined, but they also lose reputation. And if they lose reputation, then they lose potential future opportunities. So it's really important that we figure out how to break out of this cycle. So how many of you have, by a show of hands, attempted to implement something like GDPR in your organization? Okay. Now, keep your hands up if, after you implemented it, you were still not sure if you did it quite right. Yeah. So there's this disconnect between policy creation, enforcement, and implementation. By the way, I use this example. I feel like I'm the guy holding the bucket. The first time I implemented some data governance policies, the car is like the data. So here's policy as code, right? The idea now is instead of kind of these written policies, we can actually say, okay, well, let's have fun with it. Let's take these policies and convert them into code, which we love. And then we get all these benefits that we get with code: automation and consistency, improved accuracy. We can embed it in our CI/CD pipelines. And we also have audit and transparency because we have logs. So what are the elements of this? Well, at the very top here, we have the policy itself. So this is the policy expressed as code. These are our inputs. Then we have data. So an example of a policy would be all data products must have accuracy measured, right? The data could be the threshold per data product of how accurate the data needs to be. Does it have to be 90% accurate, 80% accurate? And then we have a CI/CD pipeline that runs, a pipeline that then is executed, and there's some measurement of quality in that pipeline. Then we go as the input, and then we say, okay, well, given these 3 things, do they match? So if the accuracy is greater than 80%, we're good to go, right? So that's the lower validation response here. We don't really need to explain that. I mean, it's just true, and that's fine. Move forward. If, on the other hand, it does not match, then we need both the evaluation, false, and the validation response. It's lower than 80%. You've got to fix it. Where can this be applied? So not just in data, but kind of just everywhere. You can apply it on data retention and deletion policies. You can apply it when you auto-scale resource allocation. You can apply it for different GDPR, HIPAA, quality assurance. So you really can take this theory and cross-apply it everywhere. Okay, so now put that in your DuckDB, store that temporarily. And let's talk about data mesh. So this is the framework that we want to embed policy as code into. So data mesh is this architectural paradigm that basically embraces decentralized data ownership and governance. So remember, we used to have these giant monolith kind of analytics planes where it'd be kind of one contiguous, very inflexible monolith, right? And that worked well on a small scale. But as we started to scale up, it started to have problems, right? Things started to break down. And from a governance perspective, that monolith was very comforting. It was very easy to govern the monolith. Then we have data mesh. So suddenly we've decentralized this ownership, and it's very hard to govern. And then we had this notion of these data products, just living everywhere, federated across domains, with different data assets. They encapsulate data, metadata, and ultimately policies too. So the first two principles, I think everybody has really benefited from, right? The distributed domain architecture and data as a product. So domains end up being broken down by business. There's a customer domain, or a lab experiments domain, or a clinical trials domain. And then we treat every data as a product, a self-contained unit that brings business value in that domain. And our teams are organized around domains as well. The one thing that I think a lot of people miss about data mesh is the notion of self-service data infrastructure and federated data governance. So these two things are kind of like peas and carrots. They go together really well. So not everything in data mesh is decentralized. Actually, I would argue that it's a bit kind of like a peanut butter and jelly sandwich, where you have the bread, which is the data governance at the top, the peanut butter and jelly, which are all your different data products, and then at the base, you have the data platform, which is where you can embed the self-service data infrastructure. And by doing this in a central way, you can implement some centralized data governance up here as code down here. So now, what do these two things look like together? So you have decentralized governance, that's okay, but you have centralized standards in your platform. You have computational governance, but you're also automating the policy across the entire mesh. And then you have policies embedded as the data aspect in the data products. And finally, you have lifecycle integration. So you're enforcing policies at build and runtime. And we're going to see two examples of that and how those two things work together. What are some best practices if you want to implement something like this? Well, the first thing that you want to do is, instead of the more traditional command and control top-down governance approach, you actually want to create a more collaborative approach with cross-functional teams to define your data governance policies. So there should be this feedback loop going back and forth between the data engineers and the governance team. If you were to start doing this tomorrow, I wouldn't try to do everything at once, right? Instead, kind of look at it as, let's just prioritize the policies that we care about based on risk and the impact. And then you want to make sure that because you have these policies represented as code, you're going to have different versions, right? You can put them into GitHub, and you can release different policies as versions, just like you would any other piece of code. And then you want to continually test and monitor the policy enforcement, and iterate and refine. So now you're ready to do it, and you think, okay, well, I'm going to build this into my data orchestration tool. Easy, right? I'll just put another task in that evaluates certain criteria based on the policies, and that will be my code. Done. The problem with this is it's a little too decentralized. You do kind of want a level of policy enforcement that exists at a central level. So some kind of external service that all the data products can talk to validate the certain aspects that you've written as code, right? So the enforcement of the policies. So there's some checkpoint where it's making a call, evaluating some of the information based on the three areas that we talked about, and then giving that back to the data product. So we want to separate those concerns. What are some tools? So there's so many, right? There's different policy languages that you can use. There's CEDAR policy language. There's domain-specific languages. There's Rego, which I prefer. There's different policy engines. Open Policy Agent, which we're going to use today. Infrastructure as code, absolutely. Terraform, TerraTest. I think there's a few configuration, TerraConfig, I think, as well. All these different kind of tools. And then, of course, data quality, specifically for data engineering. You want to be able to measure that in different ways. And that in and of itself is policy as code in many ways, right? By setting the rules for your data quality, that's probably something embedded in a policy. So let's look at the practical use cases. All right, so going kind of from the outside in, the first use case is how do we validate a self-service data product configuration? So this is kind of step one when you start building more automated data products, is you kind of build them as configuration. I think we saw some examples in the last talk. And basically, you really first think about like, okay, how can I represent this as configuration? Once I represent it as configuration, then I want to take that configuration as parameters for a CI/CD pipeline that provisions the infrastructure and the data product, the Git repo, everything, right? You could also build this into something like Roadie or Backstage. And basically on a pull request, once the developer or the data engineer has created the configuration, there needs to be a CI/CD process that checks at the policy enforcement level, is this configuration compliant with our policies? And then display the response. So this is an example. I've changed a lot of fields here so that kind of making sure IP protection, right? But this is an example of like what maybe a data product configuration would look like. Now, a lot of times people will go even further and build graphical user interfaces that data engineers can work with to create their own data products, which ultimately creates a configuration. And I've also seen some examples of domain-specific data product language frameworks that people have created as well. So you can get pretty advanced. But at the base level, the configuration is what we want to check. So this is our policy. So here we're just checking elements of the configuration. Do they exist or not? And if they don't, bring back a meaningful message. This isn't a perfect example, but just to give you an idea. So this was the policy data, and now we're making the query, and then we get back the response. So in the true, we just true. It's good to go. Go ahead and merge that in, and then deploy. False, we want to give the data engineers some feedback. You're missing an invalid data product policy, invalid policy enforcement configuration. Something a little more specific, but you get the general idea. So the second use case, and I think this is the one that it's more common, is that we want to validate the security policies at data products at the consumption level. So right now, I see a lot of role-based access control on the consumption layer of a data product. And what do I mean by that? Imagine you have an administrator role. You can access the database, and therefore you can access all of the tables. But instead of giving people roles, like I have maybe 10 or 15 different roles, but I don't always need all of these roles. And in fact, maybe there's too many. Maybe I have too much access. But I could be more specific if I looked at role-based access from a policy perspective. So policy-based access, where I am not just talking about roles, but also certain attributes that I have in the organization that gives me certain access to data. This is a really complex diagram, but actually, it's even more complex if you were to do the mapping of all of the users in your system if you have role-based access to everywhere else, and to try to figure out who has access to what. So in a way, policy-based access control, although complex in this diagram, can actually simplify things. And you can kind of see you have a central policy enforcement point. This is just kind of general permissions. And this is what it might look like. So here we have a doctor, which is Alice, and she is updating patient record 2, and she action is update. And then we have the user attributes, so she has clearance level 4, and she's a doctor. And then also, we have a policy. Our policy is the doctor should only be able to access records during normal business hours. Outside of that, no. There's no need for them because they work 9 to 5. They don't need access outside of business hours. And so because that's a policy, we've defined that here, allow if, during a certain date and a certain time. And of course, we've hard-coded this. Naturally, you would probably not make that hard-coded, plus or minus 5 hours or 12 hours. And then we're able to evaluate against that. So in this case, it's false. We would probably want to say, in this case, it's security. So we're not going to give too much detail about why we denied that user access. But if we had logs, we would probably want to log more information as to why that user didn't have access. So this is an example of policy-based access control that you can embed in your data product. And finally, we have AI oversight and the role of policy as code. So just because we're not working with data doesn't necessarily mean that there's no way to use policy as code with AI. So one example that I've recently noticed in another talk that I did is we populated a vector database and a graph database with a lot of different types of data. The vector database, we put data from multiple domains in that database. And it seemed that when you would query the database, it would kind of give back some kind of nonsensical chunks that maybe weren't related to the question, but they had matched. But then once we limited the access based on a policy of domain specific, so if I'm in a certain domain, I only see chunks of data in my vector database that are related to my domain, the responses and the context that was injected gave a more accurate response. So it was just kind of a happy side effect. Perhaps also we could have policy as prompt. Maybe that's the next big thing. So we can have policy as code and then policy as prompt to complement that. So we could have different ways of automated PI checks, ensure the outputs of LLMs are appropriate by self-reflection of other LLMs, that kind of thing. I think that's already happening, really. And this is the last, it's kind of scary, but we've also been experimenting with fine-tuning smaller models with domain-specific data to do one specific task. Now, the models end up not being good at anything else after you fine-tune them, but they're really good at that one thing. And I think that perhaps the next step, one thing that we could be doing in the future, is kind of looking at how could we create these kind of smaller base models to help us oversight as agents to some of the other, like the ever-expanding landscape of data, AI, LLMs, and different things that we have in our tech stack. So I don't think that it's quite there yet, but I'm very optimistic that we can get there. This was originally a interactive talk that was about an hour and a half long. So if you're curious, there are some examples here, and there's the repo as well. So if you want to try this on your own, you can clone that repo and try it later. Here is my contact information, so please feel free to reach out if you have any questions.